Sir, you can start now.
Well, 1 minute, man. I'm not gonna. Yeah. Can you see the screen? Good evening.
Good evening, sir. Yes, sir.
Yeah. Now I remember we learned so many reactions with respect to aldehydes and ketones, and we stopped with one of the named reactions called as Clemmensens reduction. We will continue from that. Clemmensens reduction. See, organic reactions. So I will write and explain. Named reactions. 4 named reactions are expected in your board exam. It can be anything. All right. Clemmensens reduction. Sorry. Now, what is this Clemmensens reduction? A process of converting a carbonyl group into methylene group, CH2 group, is called as Clemmensens reduction. A process of converting a carbonyl group into CH2 group, methylene group, is called as Clemmensens reduction. So the statement goes like this: when aldehydes and ketones are heated with zinc amalgam in concentrated HCl. Zinc amalgam in concentrated HCl, hydrochloric acid. Corresponding hydrocarbons are formed. Now, when we say corresponding hydrocarbons are formed, now you know that molecules containing only carbon and hydrogen will be called as hydrocarbons. Now, an aldehyde and ketone, the general representation we will write like this: R dash. It can be an aldehyde or a ketone. If R is hydrogen, it becomes an aldehyde. If R is other than hydrogen, they will become ketones. Now, when this aldehydes are ketones, carbonyl compounds, when you heat it with zinc amalgam, zinc and mercury is called as zinc amalgam in concentrated HCl. See, zinc amalgam in concentrated HCl is a very strong reducing agent. When we say a strong reducing agent, something which undergoes oxidation is called as a reducing agent, or some compounds which gives nascent hydrogen is called as a reducing agent. So here, 1 mole of carbonyl compound requires 4 moles of nascent hydrogen. We can write this 4 nascent hydrogen as 2 and 2, like this. So what happens? These 2 hydrogen atom and 1 oxygen gets eliminated as water. In place of this oxygen, 2 more hydrogen goes. So what is that we get? RCH2. In place of this oxygen, 2 hydrogen goes. Therefore, we get CH2 single bond R dash. This is nothing but a hydrocarbon. We will take a specific example. We will take a simple example like acetone. If we take acetone, and if this acetone is reduced using zinc amalgam in concentrated HCl, what happens? For our understanding, we write it as 2H and 2H. These 2 hydrogen and atom and oxygen gets eliminated as water. In place of this oxygen, 2 more hydrogen goes. So you get CH3, CH2, and CH3. This is propane. Propane is an example for hydrocarbon. They will ask you for 1 mark. Name the reducing agent used in Clemmensens reduction. The reducing agent used in Clemmensens reduction is zinc amalgam in concentrated HCl. You should remember the reducing agent used in Clemmensens reduction. Understood this?
Yes, sir.
Yeah. The next reaction, named reaction, we will have to learn the named reaction. Are you finding organic chemistry difficult, or you're able to follow? Because this chapter is long and you have a lot of reactions to be remembered. All right. In part D, in the new question paper pattern, part D, you have organic chemistry, wherein they give 6 questions. And in that 6 question, you're expected to write 3 questions for 5 marks each. So 15 marks will be there in part D for organic chemistry. So in alkyl halides and alloarenes, either SN1 or SN2 will be there for 3 marks, and some other named reaction like Woods reaction, Woods-Fedig reaction, all that will be there for 2 marks. So if you're finding difficult, you can skip this chapter and we can go for biomolecules, polymers, all those amines. Those are small chapters, less number of reactions. So next is another named reaction that's called as Wolff-Kishner, Kishner, Wolff-Kishner reaction. Now, what is this Wolff-Kishner reaction? When a carbonyl compounds are heated with hydrazine in the presence of alkali, hydrocarbons are formed. That is called as Wolff-Kishner reaction. So when a carbonyl compounds, aldehydes or ketones, are heated with hydrazine, in the presence of alkali, hydrocarbons are formed. This reaction is called as Wolff-Kishner reaction. Now, for an example, if you take a simple molecule like this, if you take acetone like this, hydrazine we have learned already, condensation reaction we have learned, NH2 is hydrazine. So what happened? H2O gets eliminated as water. In place of O, this nitrogen gets bonded. We get CH3, double bond N, NH2. This is called as hydrazone. It is called as hydrazone. This, when it is hydrolyzed in the presence of potassium hydroxide and glycol. So what happens is these nitrogen atoms gets eliminated as N2, nitrogen gas. Since we are hydrolyzing in the presence of a base H2O, this hydrogen and this oxygen gets eliminated as water. So what we have now, we have CH3, C double bond is there. In place of this double bond, 2 hydrogen gets bonded. So you get CH2 and we get CH3. This is nothing but a hydrocarbon. So this is called as Wolff-Kishner reaction. So a process in which a carbonyl compound is heated with hydrazine and in the presence of alkali. See, alkali, potassium hydroxide is an alkali. Hydrocarbons are formed. So this reaction is called as Wolff-Kishner reaction. Now coming to the next reaction, that is oxidation. So we should remember aldehydes on oxidation gives carboxylic acids. So aldehydes on oxidation gives carboxylic acid. Now the strong oxidizing agent is acidified potassium dichromate. The next reaction is oxidation of aldehydes. So this is not general, it is specific. Oxidation of aldehydes. So aldehydes can be easily oxidized. This is an important question you should remember for competitive exam. Aldehydes can be easily oxidized to the corresponding carboxylic acid. Carboxylic acid. By heating with oxidizing agents like acidified potassium dichromate or acidified potassium permanganate. These are common oxidizing agents, a very strong oxidizing agents. Potassium dichromate and sulfuric acid, potassium permanganate and sulfuric acid. These all are a good oxidizing agent. Now, if you take an aldehyde, for an example, acetaldehyde, if we take this acetaldehyde, when you heat it with acidified potassium dichromate, K2Cr2O7, in dilute sulfuric acid. Now, potassium dichromate will react with dilute sulfuric acid to give nascent oxygen. Now, since it gives nascent oxygen, this is called as an oxidizing agent. This oxidizing agent attacks the carbon. So what's that we get is, we get CH3, C double bond O. This O remains as such. The mechanism is different. The bond breaks here. I'm not showing the mechanism. So in place of H, oxygen and this hydrogen gets bonded. So CH3COOH. This is nothing but carboxylic acid. The name of the acid is acetic acid. Now, what is that you're supposed to remember? Now, aldehyde contains 2 carbon atoms, the acetaldehyde. The carboxylic acid also contains 2 carbon atoms. So, when aldehydes are oxidized, a corresponding carboxylic acid is formed, which contains same number of carbon atoms as aldehyde. So this is acetic acid, contains 2 carbon atoms, and here it's acetaldehyde. It also contains 2 carbon atoms. Now, if ketones are oxidized, now for an example, if you oxidize acetone, this is ketones. The same reaction will perform with a ketone. This ketones, when you oxidize in the presence of acidified potassium dichromate, K2Cr2O7, dilute sulfuric acid. So what happens is, this involves the cleavage of strong carbon-carbon bond. There will be a strong carbon-carbon bond broken. Now, when we say strong carbon-carbon bond breaks, now here, in this case, the carbon-carbon bond will be broken here. So what happens? Now, since it is an oxidation process, this molecule has to give nascent oxygen. We get acetic acid. There will be 2 acids. One is CH3COOH, acetic acid, and the other one is formic acid, HCOOH. So here, oxidation will take place. So cleavage of carbon to carbon double bond takes place. Now here, if you observe, here it has 3 carbon atoms, but here the products have, this has 2 and this has 1. So whenever ketones are oxidized, we get carboxylic acid containing less number of carbon atoms. Remember, aldehydes will give same number of carbon atoms. Ketones will give carboxylic acid containing less number of carbon atoms. So all these reactions with nucleophilic addition reaction, we've learned hydrogen cyanide mechanism I taught you in the previous class. This is the reaction products, different reactions. Sodium bisulfite I taught you, and this reaction will not take place with acetophenone, I told you, because of steric hindrance. All that we have learned. Acid catalyzed reactions. So all these reactions we have learned. Grignard reagent, I told you, primary, secondary, tertiary alcohols are formed. All this been taught. Now coming to some of the oxidation reactions. Can you see the screen?
Yes, sir.
Yeah. Now some of the reactions more we have to learn. So I'll erase and write and explain because I am not satisfied with the material there. So organic reactions, if we write, we understand better. The next one is aldol condensation reaction. The name of the reaction is aldol condensation reaction. Aldol condensation reaction. Now, what is this aldol condensation reaction? Before we learn aldol condensation reaction, now we need to know the condition for aldol condensation reaction. Now, formaldehyde, if you write HCH double bond O. This is the functional group. CH is the functional, CHO is the functional group. This functional group containing carbon is not bonded to any other carbon. Now, we will take another example. If we take CH3, C double bond O, double bond, C double bond O, CH. This is acetone. This is acetone. Now, this is the functional group. Carbon atom attached to the functional group will be called as alpha carbon atom. So these hydrogen atom attached to alpha carbon atom will be called as alpha hydrogen atoms. What are alpha hydrogen atoms? Hydrogen atoms attached to alpha carbon atom is called as alpha hydrogen. What is alpha carbon atom? Carbon atom bonded to the functional group is called as alpha carbon atom. Now this is acetone. Now if I take an example, CH3, CH, double bond O. This is acetaldehyde. This acetaldehyde also contains alpha carbon atom. This is the carbon bonded to the functional group. So this alpha carbon atom contains hydrogen. Therefore, these are called as alpha hydrogen. Now, in case of formaldehyde, now there is no alpha carbon atom because this molecule contains only one carbon. Since it contains no alpha carbon atom, this molecule contains no alpha hydrogen atom. No alpha hydrogen atom. Likewise, if you take a molecule like this, benzaldehyde, this benzaldehyde, this is alpha carbon atom. This is alpha carbon atom. But this alpha carbon contains no hydrogen. Since this carbon contains no hydrogen, this benzaldehyde also contains no alpha hydrogen atoms. So if a molecule contains alpha hydrogen atoms, they will undergo aldol condensation reaction. If a molecule contains no alpha hydrogen, they will undergo Clemmensens reaction. So conditions you should remember. What is the condition for a molecule to undergo aldol condensation? The condition for a molecule to undergo aldol condensation, the molecule should contain minimum of one alpha hydrogen. So if a molecule contains minimum of one alpha hydrogen, they will undergo aldol condensation. If no alpha hydrogen, then they will undergo Clemmensens reaction. Did you understand the reason? Did you understand the conditions? Did you understand the conditions?
Yes, sir.
Now, if that's the case, now what type of molecules will undergo aldol condensation? Molecules containing alpha hydrogen. Now, example for molecule containing alpha hydrogen, I gave you acetone, I gave you aldehydes. No, not acetaldehyde, sorry, not aldehyde, acetaldehyde. Now, we will learn first aldol condensation, then we will learn the Clemmensens reaction. Now, for an example, if this is acetaldehyde, C double bond O and H, CH3, CHO, this is acetaldehyde. Now, this is also acetaldehyde representation. CH3, CHO, both are acetaldehyde. When acetaldehyde, which contains alpha hydrogen, shaken with aqueous sodium hydroxide, what happens, you see? This hydrogen attacks oxygen. When this hydrogen attacks oxygen, what happens? The pi bond breaks. When the pi bond breaks, this carbon attacks this carbon. So the product, what we get is we get CH3, C single bond, OH. Here you already have an H. Here you have CH2 and CHO. Now this molecule, you can see it contains an aldehyde group as well as it contains an OH group. Therefore, it is commonly called as aldol. Molecule which contains an aldehyde group and alcohol group is called as aldol. Now, what's the name of this aldol? Before we could write the name of this aldol, Now, if I write in place of this hydrogen here, if I write this hydrogen atom like this for our understanding, it's all the same. So what will be the name of this molecule? 1, 2, and 3. So 4. So therefore, it will be butane. Since we have an aldehyde group, we have butanol. But what butanol? It is called as 3-hydroxy. This is alpha carbon atom. This is beta carbon atom. So therefore, we can name this as beta hydroxy butanol. So this can be called as this beta hydroxy butanol or 3-hydroxy butanol. When you heat, what happens is this H and OH gets eliminated as water. When H and OH gets eliminated as water, we have CH3, CH. Here a double bond will be formed, and you have CH and CHO. This molecule is called as 2-butanol. 2-butanol. The common name for this molecule is crotonaldehyde. Crotonaldehyde. Similarly, instead of acetaldehyde, ketones also can undergo this reaction. Ketones also can undergo aldol condensation reaction. Please observe this. What will be the statement? When aldehydes or ketones containing alpha hydrogen atom is shaken with an alkali like sodium hydroxide, it undergoes self-condensation reaction to form beta hydroxy aldehydes, or if we take ketones with beta hydroxy ketones, this beta hydroxy aldehydes on heating, it decomposes to give crotonaldehyde. This is important. This is very fast reaction. This is a fast reaction, and it is called as dehydration. The water gets removed. Therefore, it's called as dehydration. The next reaction is Cannizzaro's reaction. Now, what is this Cannizzaro's reaction? What's the condition for a molecule to undergo Cannizzaro's reaction? The molecule should not contain alpha hydrogen. So, if a molecule does not contain alpha hydrogen, they will undergo Cannizzaro's reaction. So, if a molecule has to undergo Cannizzaro's reaction, the molecule should not contain alpha hydrogen atom. So Cannizzaro's named reaction, Cannizzaro's reaction. Now this Cannizzaro's reaction is what type of reaction? It is oxidation reduction reaction. It is not redox. It is not redox, remember. So it is oxidation reduction reaction. So Cannizzaro's reaction is not a redox reaction as we learn in electrochemistry. Here it is a different concept. So, but both oxidation and reduction will take place. Now, for an example, if we take formaldehyde, HCHO, formaldehyde, this does not contain alpha hydrogen. This formaldehyde, when you shake it with concentrated sodium hydroxide, what happens is we get an alcohol here, methanol, and you get a salt of carboxylic acid. So you get methanol and sodium formate. Sodium formate. Likewise, if we take benzaldehyde, C6H5CHO, 2 moles of benzaldehyde. Now, this 2 moles of benzaldehyde, when shaken with 50% sodium hydroxide or concentrated sodium hydroxide, you get benzyl alcohol and you get sodium benzoate. Now, see, the salt is an oxidation product and alcohol is the reduction product. If you take benzaldehyde, you have 7 carbon atom, 6 hydrogen atom. 6 plus 1, 7 carbon atom, 6 hydrogen. If you take reduction product, this alcohol, if you take 7 carbon atoms there, but 5, 6, and 8 hydrogen. So addition of hydrogen is called as reduction. And here, if you see only 1 oxygen atom is there, in the salt, we have 2 oxygen atoms. Therefore, this is called as oxidation product. So Cannizzaro's reaction is an oxidation reduction reaction. So Cannizzaro's reaction, the molecule should not contain alpha hydrogen. So no alpha hydrogen. A molecule containing no alpha hydrogen atom, when treated with alkali at room temperature, and corresponding alcohol and sodium salt or the salt of carboxylic acids are formed. This is called as Cannizzaro's reaction. Can you remember? Can you understand this statement?
Yes,
Should
sir.
I write?
No, sir.
No? You want me
Yes,
to
sir.
write the statement?
No, sir.
Yeah. Now, the other two named reaction we have. We will learn the other two named reaction quickly. The third named reaction what we have to learn is called as Clemmensens reaction. This is also called as Clemmensens condensation reaction. What is this Clemmensens condensation reaction? Base catalyzed cross-aldol condensation reaction between aromatic and aliphatic aldehydes or ketones is called as Clemmensens condensation reaction. So Clemmensens condensation reaction is base catalyzed cross-aldol condensation. Cross-aldol condensation reaction between aromatic aldehyde and aliphatic aldehyde or ketone is called as Clemmensens reaction. Now, for an example, if we take benzaldehyde, we can write benzaldehyde like this: C6H5, C double bond. This is an aromatic aldehyde. If I write acetaldehyde like this, H2CH-CHO. CH3CHO is called as acetaldehyde. This is acetaldehyde. This is benzaldehyde. So this in the presence of a base like sodium hydroxide, what happens? This H and this OH gets eliminated as water. When this H and OH gets eliminated as water, this carbon goes in the place of oxygen. So you get a benzene ring. You have CH, double bond, CH, CHO. This is called as cinnamaldehyde. This is called as cinnamaldehyde. This reaction is called as cinnamaldehyde. So this is called as Clemmensens reaction. Followed base catalyzed cross-aldol condensation, aromatic aldehyde and aliphatic aldehyde. They undergo condensation called as cross-aldol condensation. The product formed here in this case is cinnamaldehyde. The next reaction the last named reaction in this chapter is called as Perkins reaction. Perkins, Perkins reaction. So when benzaldehyde is heated with acetic anhydride, when benzaldehyde is heated with acetic anhydride, in the presence of sodium acetate, cinnamic acid is formed. Cinnamic acid is formed. This is called as Perkins reaction. So when benzaldehyde is heated with acetic anhydride in the presence of fused sodium acetate, cinnamic acid is formed. We can write benzaldehyde like this. This is benzaldehyde. When this benzaldehyde is heated with acetic anhydride, it's CH3CO, CH3CO, and oxygen. This is called as acetic anhydride. When we heat this in the presence of sodium acetate, CH3CO, and it is sodium acetate. Now what happens is the bonds will break here. The bond breaks here. When bond breaks here, what happens is now this happens in the presence of water, fused in the presence of water, or maybe we can write like this. We can write not water, we can write it like this. This CH3, I write as CH and H2. CH3CO, I've written it as H2CH for our understanding. What happens is there will be a reaction. This water gets eliminated, not directly eliminated as a byproduct. This water which is formed, hydrogen will attack this oxygen, OH will attack this carbon. So what is the product you get? I'll explain it again. C6H5, you have CH, you have a double bond here, you have CH, you have single bond COH. This is called as cinnamic acid. Cinnamic acid. This is a product. Now, what's the byproduct you get? The byproduct, what you get is CH3COH. The byproduct we get is CH3COH. Now, this is benzaldehyde. This benzaldehyde, when it's heated with acetic anhydride in the presence of sodium acetate. See, CH3CO is called as acetic anhydride. Now, what happens is, in the presence of sodium acetate, the bond between carbon and oxygen breaks. Likewise, 2 hydrogen atom of this carbon reacts with oxygen to form water. In that water, hydrogen attacks CH3CO and forms acetic acid. OH attacks this to form cinnamic acid. Did you understand this reaction? This is called as Perkins reaction. So a lot of named reaction we have learned. Now, uses of aldehydes and ketones, you can read it from any of the material. You can learn the uses of benzaldehyde, acetaldehyde, or acetophenol. All that you can learn. Now we have the next part of the topic that is called as carboxylic acid. We have to learn about carboxylic acid. We'll learn about carboxylic acid. A lot of reactions we have learned. Where's carboxylic acid gone? Yeah. All right. Just give me a moment. All right. Now, carboxylic acid we will see here. This is Clemmensens reaction. Aldol condensation, you learned. Claisen condensation. All right, carboxylic acid I'll teach you here. Material is it's not found here. It seems to be missing. Anyways, we will learn now here. Carboxylic acid. Now, carboxylic acids are compounds which contains COOH as the functional group. Organic compounds which contains COOH as a functional group will be called as carboxylic acid. Now, the general formula of the carboxylic acid is R COOH. The structure is R, C double bond O, OH. This is the structure of carboxylic acid. Now we have to learn something called as the classification of carboxylic acid. Now classification of carboxylic acid, depending on the number of OH groups, carboxylic acids are classified as mono, di, tri, etc. And based on the nature, structure, it can be either aliphatic or aromatic. Now aliphatic carboxylic acids like acetic acid, propanoic acid, all those are aliphatic. Now this is aliphatic. But if you take a benzoic acid like this, C6H5COH, this is aromatic acid. So any carboxylic acid which contains a benzene ring will be called as aromatic carboxylic acid. Now we have to learn the general methods of preparation of carboxylic acids. We will learn the general methods of preparation of carboxylic acids today. Possibly next week, we can learn the chemical properties because we don't have much of time. So we'll have to learn only with the preparation of carboxylic acid, manufacturing or preparation of carboxylic acid. The first method is from alcohols. Now, we all know that primary alcohols on oxidation gives aldehydes. Primary alcohol on oxidation gives aldehydes. This aldehyde on further oxidation, gives carboxylic acid. Now, first method of preparing a carboxylic acid is by oxidation of primary alcohol. Now, primary alcohol, for an example, we'll take ethanol, CH3, CH2, OH. Or we can write it, in order to explain, we will write it like this, CH3, CH, and H. This is ethanol. When this is oxidized using a strong oxidizing agent like acidified potassium dichromate, this H and this H and this O gets eliminated as water. We get CH3, CH, double bond O. This is called as acetaldehyde. This acetaldehyde on oxidation, again, further oxidation with a strong oxidizing agent. So what happens? This attacks the hydrogen. Therefore, you get CH3, COH, double bond O. Or we can write this as CH3, COH. This is nothing but carboxylic acid. Primary alcohols on oxidation gives aldehydes. This aldehydes on further oxidation gives a carboxylic acid. This is one of the method of preparing a carboxylic acid. Now the second method of preparation is this. From alkyl benzenes. Second method is from alkyl benzenes. So alkyl benzenes on oxidation gives carboxylic acid. Now for an example, if you take toluene, C6H5, CH3, this is alkyl benzene. This is commercially called as toluene. This toluene, when you heat it with potassium permanganate, alkaline potassium permanganate, strong oxidizing agent, alkaline potassium permanganate, this toluene will be oxidized to benzoic acid. So aromatic carboxylic acid, like benzoic acid, can be prepared by the oxidation of alkyl benzene. So alkyl benzenes, like toluene, on oxidation, alkaline potassium permanganate, followed by hydrolysis or acidification, you get benzoic acid. This is called as benzoic acid. Followed?
Yes, sir.
Okay. Now, the third method of preparing carboxylic acids. The third method of preparing carboxylic acid is from cyanoalkanes, or it is also called as alkane nitriles. Alkane nitriles. So alkane nitriles are cyanoalkanes or boiled with dilute hydrochloric acid or sodium hydroxide followed by acidification, yields, followed by acidification, 1 minute, something wrong, followed by acidification yields carboxylic acid. Now, this alkane nitrile, for an example, we will take ethane nitrile. This ethane nitrile, cyanides or nitrile, the bonding between carbon and nitrogen is a triple bond. Carbon and nitrogen is a triple bond. This, when you boil with dilute hydrochloric acid, it is hydrolysis. Dilute hydrochloric acid means it will undergo hydrolysis. Now we can write this as, now hydrogen attacks nitrogen and this oxygen attacks carbon. Therefore, you get a CH3CONH2. You get an amide. This amide, when you acidify or further hydrolyze, so what happens, you see, water I can write H and I can write it as OH. So what happens? So you get a carboxylic acid, CH3COH, you get, plus the byproduct what we get is 1. So the third method of preparing a carboxylic acid is by use of alkane nitriles or cyanoalkanes. Cyanoalkanes boiled with dilute hydrochloric acid or sodium hydroxide, you get an amide, followed by hydrolysis, we get a carboxylic acid. Now, the next method of preparation of carboxylic acid is prepared from esters. E-S-T-E-R. Esters are organic compound which contain COO as a functional group. Molecule containing COO as a functional group is called as an ester. So from ester, how can we prepare carboxylic acid from esters? Now, CH3, CH2, COO, CH3. This is an ester. This ester, when you hydrolyze in the presence of an acid, so what happens is the bond break between carbon and oxygen. OH gets attacked to carbon and hydrogen attacks to oxygen. So you get CH3, CH2, COOH, plus you get CH3OH. This is carboxylic acid. This is propanoic acid. Similarly, you can prepare aromatic acids also. Now, the last method of preparation we will learn, and we will see whether we can continue with the chemical properties or not. Right. So the last method is from acid chlorides. From acid chlorides. An example for an acid chloride is acetyl chloride. This acetyl chloride, when you hydrolyze, when you hydrolyze. We can write H and OH. So in the presence of an acid, what happened? H and Cl gets eliminated as HCl. In place of H, OH goes. In place of Cl, OH goes. So what we get? We get CH3, C double bond O, and OH. This is nothing but acetic acid. So acid chloride also on hydrolysis, we get carboxylic acid. So chemical properties of carboxylic acid, physical properties and chemical properties we will learn. Before that, we have one more method of preparing carboxylic acid. The last method, we will learn that, and then we'll stop for today. The last method of preparation of carboxylic acid in our syllabus prescribed is from amides. From amides. From amides. Amides are organic compound which contains CONH2 bond. This is amide. CONH2 is called as an amide group. So name of this molecule is acetamide. This acetamide, when you hydrolyze in the presence of an acid, so the bonds between carbon and nitrogen breaks. Water, hydrogen reacts with nitrogen to form ammonia, and OH attacks this carbon. Therefore, the product what we get is acetic acid, and we get ammonia. Did you follow? So many methods, we have learned it in a little fast.
Yes, sir.
Followed. Okay, we'll continue the class next month. Bye.
Thank you, sir.